So let's go back to the PowerPoint, and I'm actually going to show you how to put this in the calculator. So I have got data right here that shows, I've been talking about this data for a little bit during this PowerPoint. It's 11 statistics students, and I want to see how they do on their third exam compared to their final exam. We saw this in one of the scatter plots. So what it wants me to do is make the best fit line for this data. So let me bring my calculator up. Come back up. All right, so I'm going to turn it on. And if you can see here, I went to Stat, Edit, and I put all my values in there. And if you scroll down, you'll see that I put all 11 in there. So remember, each X has to have a corresponding Y. If not, it will not run this. So then what I'm going to do is I'm going to go Stat, over to Calculate. Okay. This is the one that I talked about in the PowerPoint previous to this. And this is the one that the book uses. They look kind of confusing, but remember, whatever is next to X is the slope. Whatever's not near X is the y-intercept. So you choose the one that makes sense to you. I always use 4, the LNREG. That's what I was taught. That's what I use. So I'm going to go to 4 and hit enter and then hit enter again. But I made a mistake because I didn't go do my diagnostic on. So all I need to do is hit mode. Let me go down. It's going to be a little bit different. Oops. Nope, mine doesn't do that. Okay, so if your calculator, like my calculator, doesn't do that, there's another way to do it. So we're going to get out of there. Oops, we're going to clear it. And I'm going to do second 0. And this is my catalog. I don't know if you've seen this, but if you have trouble sometimes finding a function, you can find stuff quickly. So I'm going to go to diagnostic on, keep going down, and I hit enter, and then I hit enter again. Because what that does is it's got to say diagnostic on and then done. And that's what it does for me. So then I'm going to go back to stat, go over to calc, hit 4, and then hit enter. Okay, so it gave me a bunch of data. The first thing it gave me is y equals ax plus b. Well, again, for this one, a is the slope, 4.82 is my slope, b is my y-intercept, which is negative 173.51. R squared is 0.4396, and r is 0.6630. We will talk about this in more detail in a few minutes, but I just wanted to show you where I got it. So, again, from the last slide you see here, and I just wrote it in a different form. Here's y-intercept and here's the slope. You can flip them. It's whatever you're comfortable with. So remember, it's always important to plot the scatter diagram first. If the scatter plot indicates there's a linear relationship between the variables, then you can make the line of best fit. But when you do that, it's not necessary for all the x values outside that domain. So think about it this way. On the last example, I could predict a grade of 73 because, look, my data ranged from 65 all the way to 75. So could I estimate a grade of 73? Absolutely. What I couldn't do was estimate a grade for 50 because 50 is not between that range because the sample data was between 65 and 75. People do this a lot. They use different values outside the range to predict stuff. Don't do that. Keep it as it is, and you should be fine when you stay within the range. So, all right, let's understand that slope. The slope of the line, we put B here, and remember, it can change. It can be A, depending on what calculator setting you use. It describes that the change in the variables are related. It's important to interpret the slope of the line in context of the situation explained by the data. You should be able to write it in a sentence to explain the slope in plain English. Okay, so interpretation of the slope. The slope of the line of best fit tells us how the dependent variable y changes for every 1 unit increase for the independent variable of x. So for the third exam and the final exam example, the slope was 4.83. So that means for a 1-point increase in the score on exam 3, the final exam score increases by 4.83 points. Okay, does that make sense? So I showed how for every one of X, which is the third exam, the final exam increases by 4.83 points. All right, let's talk about the coefficient R. So besides looking at the scatter plot and seeing if the line seems reasonable, you can see if it's a good predictor. So we use something called the correlation coefficient, which is R. So it was developed in the early 1900s by Carl Pearson, and it's numeric, and it provides a measure of strength and the direction of the linear association between X and between Y. And if you see here, that really nasty formula, there's a lot going on there, but we don't ever have to worry about it because the calculator does it for us. So if you're thinking there's a linear relationship between X and Y, all you have to do is see how R can measure how strong that linear relationship is, okay? So, other things about R. The value of R is always between -1 and +1. So, just think about you'll never have an R of 2 or 5 or -10. The size of the correlation of R indicates the strength of that's a typo, linear relationship. Okay, why is it a linear relationship? Because remember, we were talking about that linear relationship between X and Y. R tells us the strength of it. So if your R is near -1, that means it's a very strong negative relationship. If your R is close to +1, that means it's a strong positive relationship. When it's sitting near -1 and +1, that's a strong linear relationship. If it's 0, that means there is no linear relationship. Nothing's going on. You don't want to use it. So in the real world, you're hoping that all those data points lie in a straight line. But of course, in the real world, that's never going to happen. Okay, so what does the sign of R tell us? A positive means that when X increases, Y tends to increase. And when X decreases, Y tends to decrease. A positive correlation. The negative value of R means that when X increases, Y decreases, or when X decreases, Y increases. The sign of the R is the same as the sign of the slope of the line of best fit. Okay, a strong correlation does not suggest that X causes Y or Y causes X. We say correlation doesn't imply causation. You're just seeing if there is any kind of thing between if something going on between the two. You're not saying that one causes the other. You're just trying to see if there's a relationship. Okay. So if you're looking at the scatter plot, A is a positive correlation because it's going up. Remember, from left to right. B is a negative correlation because it's going down. And then C, there's no correlation. Remember, we looked at this before with slope. It's almost the exact same thing. All right, the coefficient of determination, R squared. This variable is the square of the correlation coefficient, but it's usually stated as a percentage rather than in decimal form. I know the calculator gives it to you in decimal form, but you want to make it a percentage. R squared, when expressed as a percentage, represents the percentage of variation in the dependent variable, Y, that can be explained by the variation in the independent variable, X. So what does that mean again? We're saying that the variation in Y can be explained by the variation in X. So 1 minus R squared, when expressed as a percentage, represents the percentage of variation in Y that is not explained by X. So in the real world, what I can do is I can do my R squared, which will explain the variation of Y explained by X. But in the real world, one thing isn't always controlled by another. So when you do a huge linear regression, you can have many different X's that can explain what's changing in Y. But for this class, we're only going to have one X and one Y. So, all right, let's go back to that data. There's my line of best fit. There's my correlation coefficient of 0.6631. My coefficient of determination, which was R squared. Let me put that right there because that's kind of tricky. When you see it, you don't see that I put the little symbol there. Okay, so that squared is 0.4397. Okay, that's all I did, but you don't even really have to do it by hand because the calculator gives it to you. Okay, so let's interpret r squared. Well, let's jump back up to r right here. The correlation coefficient 0.6631. So we know it's positive. Why do we know it's positive? Because there's no negative sign in front of it. And we know that it's kind of between 0 and 1. 0 being no relationship, no strength, no nothing, and 1 being a strong positive relationship. So I would say this is a strong, moderate relationship between the two. Excuse me. So now let's look at r squared. So my r squared is 0.4397. I'm going to convert it to a percentage. So I'm going to say approximately 44% of the variation in the final exam grades can be explained by the variation in grades on the third exam using the best fit regression line. So all I did is I put r squared as a percentage, and then I put my y variable, and then I put my x variable. Go back to the last slide if you need it, and you can just write it out that way. That's all the book is looking for. So basically, but what does that mean? It means 44% of final exam grades are attributed to the third exam. That's okay, but that's not really explaining. That's not even more than half of what can explain it. So when I do 1 minus 0.44, I get 5.56, which means that 50% of the variation in final exam grades can't be explained by the third grade. So you've got to kind of think of it as this can be explained by this, but this can't be explained by this. So that's exactly what we're doing with r squared.